Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraina Aqila binti Burhanudin. My metric number is P122310085. Today I will present to you our antenna engineering assignment entitled T-type CPW liquid detection sensor with omega shape defected ground structure DGS. Our project focus on designing a microwave antenna sensor that can be used for liquid detection application, and the antenna was designed and simulated using CST Microwave Studio, followed by the fabrication process for prototype development. Now I will begin with the antenna design process. This slide shows the initial antenna design, which is the antenna was first designed using CST Microwave Studio according to the project specification. We selected a coplanar waveguide or CPW feeding structure together with an omega shape defected ground structure, also known as DGS. The purpose of using the omega shape DGS is to improve the antenna's sensing performance and enhance impedance matching. The initial design was targeted to operate within the frequency range of 1.35 GHz to 2.43 GHz, which is suitable for microwave liquid sensor application. However, since this was only the first design, further optimization was still required to improve its overall performance. After completing the initial design, we proceed with the optimization process. Several antenna dimensions were modified one by one using the parametric analysis feature in CST Microwave Studio. Parameters such as the width, length, and dimensions of the omega shaped DGS were adjusted to observe their effects on the antenna performance. The objective of this optimization was to obtain better impedance matching while achieving the target operating frequency range at 1.35 GHz to 2.43 GHz. After several iterations, the optimized design provided better performance compared to the initial design and was then prepared for fabrication. After obtaining the optimized antenna design, we proceed with the fabrication process, which is firstly the fabrication consists of 7 main steps, which is first the PCB layout was exported from CST Microwave Studio. Second, antenna pattern was transferred onto the PCB using a vacuum exposure unit. And third, the PCB was etched using a chemical solution to remove an unwanted copper layer. And for the fourth, the PCB was further processed using a double spray etching machine to ensure the copper was completely etched. And next, the PCB was rinsed with clean water to remove any remaining chemical on the PCB. And after that, the PCB was dried to eliminate moisture before further handling. And lastly, the PCB is inspected and cleaned to ensure the antenna was ready to assembly. I will explain the measurement setup for this assignment, which is after the antenna was successfully fabricated, the measurement was carried out inside an anechoic chamber to minimize unwanted electromagnetic reflections and provide a control testing environment. And then the fabricated antenna was connected to an angelic vector network analyzer or VNA through a SMA connector. Before the measurement, a SOLT calibration was performed to ensure the accuracy and reliability of the measurement system. The purpose of this setup measurement was to evaluate the antenna performance by measuring the S11 parameter and comparing it with the CST simulation result. So now I will move to the simulation result, which is from this slide you can see this graph shows the S11 parameter, also known as the return loss, which is used to evaluate the antenna's impedance matching. An antenna is generally considered to perform well when the S11 value is below negative 10 dB. Based on the simulation, our antenna achieved an S11 value below negative dB from 1.35 GHz to 1.76 GHz, which means the antenna operates effectively within this frequency range. The lowest return loss is exponentially approximately at negative 50 dB at around 1.56 gigahertz, and this indicates excellent impedance matching, meaning very little signal is reflected back to the source and most of the power is transmitted through the antenna. And these results can confirm that the proposed antenna successfully resonate within the intended operating band. However, the antenna has not yet covered the full target frequency range, which is from 1.35 GHz to 2.43 GHz. Therefore, additional optimization is still required to extend the bandwidth and improve the antenna performance. Overall, the simulation demonstrates that the proposed design has good potential for liquid detection application, but further improvements are needed before the final implementation. Next, I will explain to you for the measurement outcome, which is the measurement was successfully carried out using the vector network analyzer. After completing the SOLT calibration process, the fabricated antenna was successfully connected to the VNA, and the measurement was performed under laboratory condition. However, the expected S11 resonant response could not be obtained during the measurement. Therefore, the experiment performance of the fabricated antenna could not be validated. This may be due to the several factors, which is such as fabrication tolerance, SMA connector or soldering quality, or even impedance mismatch or measurement setup limitation. Therefore, further optimization and repeated measurement are required to validate the antenna performance and achieve results that are consistent with the CST simulation. For conclusion, the proposed T-type CPW liquid detection sensor with an omega-shaped deflected ground structure DGS was successfully designed, optimized and fabricated using CST Microwave Studio. The simulation result demonstrate good impedance matching with an S11 value below negative 10 dB, indicating the proposed antenna has good potential for liquid sensing applications. Although the measurement setup was successfully completed using a vector network analyzer, which is VNA, a valid S11 response could not be obtained during the measurement. Therefore, further improvements to the fabricated prototype and repeated experimental measurements are required to validate the antenna performance and evaluate its sensing capability with different liquid samples.